Hello, guys. Am I audible now? Hello, am I audible, guys? Great, great. So maybe there was an issue somewhat. Now it's fine. Great. I am clearly audible, right? Great, I am audible now. So let's quickly begin with the session today. Okay. So in today's session, the first topic that we will be going to cover is neural networks. Okay. And in yesterday's session, we have covered two topics. The first one is hyperparameter tuning. We have seen how can we like train the models. Then we saw how can we apply the hyperparameter tuning. That is, how can we get our models more accuracy. Okay, and the second topic that we have covered yesterday was ensemble learning. I hope everything was clear. I hope everything is clear. Okay, guys. So let's continue with today's topic. Okay. Yes, tomorrow is the last day of the bootcamp. Getting an accuracy is 1.0 is not that okay because it's a condition of overfitting. Like we say, too good to be true, right? So it's a condition of overfitting, we call it. When we get 100% accuracy on training data and very less accuracy on test data, or when there is a very much difference in training and testing accuracy. So it is not a good thing to get 100% accuracy. Okay, so let's quickly now begin with today's session. And let me just share my screen. I hope my screen is visible, right? I hope my screen is visible, right, guys? Okay, the previous topics we will cover in tomorrow's lecture. Like, if anyone have any kind of doubt in any of the previous topic, we will cover in tomorrow's lecture. Because right now the topic we have to cover is a very lengthy topic, we can say. So let's start with that topic first. Yes, the closer the accuracy of training and testing both is, the better model you will have. Okay, so let's quickly start with the today's topic, that is neural networks. So first of all, what is neural networks? When scientists, in a very easy language, when scientists try to, sorry, not scientists, when engineers or coders try to copy human brain. Okay, when we try to copy human brain, or when we try to make a model, when we try to make a model that can mimic human brain. From there, we generated the neural networks. Neural networks is nothing but we can call a system of interconnected nodes. Okay, so we have some nodes like these, and all of these nodes are connected to each other. All of these nodes are connected to each other, and at the end we get some kind of output after some pre-processing. Okay, so the very basic step in neural networks, the very first thing in neural networks that we must understand is perceptron. Sir, what is perceptron now? Perceptron is a single layered neural network. Okay, it is a single layered neural network. In the case of a perceptron is a single layered neural network, and in the case of a perceptron, the first thing we have, the first thing we have is our input layer. Okay, let's say we have three inputs. The first thing we have our input layer. In between we have our hidden layer. Okay, in between we have our hidden layer, and at the end we have some kind of output layer. All of these input layers are connected to each other. All of these hidden layers are connected to all of these neurons, sorry, all of these nodes or all of these neurons are connected to each other. We give some kind of input, some kind of processing is done in the hidden layer, and we get some kind of output at the end. Okay, now this is my input layer, this is my hidden layer, and this is my output layer. I hope this much is clear. First of all, I hope this much is clear. First of all, am I right, guys? I'm going to pick these neural networks topic from the scratch, and I will try to explain all of the concepts in easiest way possible. Okay, I hope this much is clear. Great, let's move on. Okay, sir, let's take an example first. So let's take an example. Suppose we have a data set in which one column is steady. So this is a very famous example. Most of the people, when trying to teach the deep learning part, use this example. Suppose we have three columns: study, sleep, and play. Okay, and we have to predict whether the person or whether the child will going to be pass or fail. Okay, so this is my output column, and these are my input columns. Now let's say the student studies for 2 hours, sleeps for let's say 6 hours, and plays for 4 hours. So I am going to say the student is going to let's say fail the exam. Okay. Now there is one more student, let's say he studies for 4 hours, he sleeps for 6 hours, and he plays for 4 hours. So I am going to say the student is going to pass the exam. Okay. So I have a data set like this. I have a data set like this. Okay. Now let's say I am referring my fail as 0, and I am referring my pass as 1. Okay. I am referring my fail as 0 and pass as 1. So what I will write, I will simply write 0 over here and 1 over here, where 0 is my fail and 1 is my pass. I hope this much is clear. Okay. So these are my this study, sleep, and play. These three are my input features. Okay. Study, sleep, and play are my input features, and this pass or fail is my output feature. So can I say that? Can I say that I will now have a I will now have a neural network like I will have a neural network like these are my input features, this is my hidden layer, and this is my output layer. Okay, sorry. Yes, this is my hidden layer and this is my output layer. Okay, so I have input features. I have input features as x1, x2, and x3, where x1 is nothing but study, x2 is nothing but play, and not play, sorry, sleep. X2 is sleep, and x3 is play. Suppose I have more than three features, suppose I have one more column over here, so I'm going to add one more neuron over here. But right now I only have three features, so I'm going to add only three neurons. I hope this much is clear now. Okay, so all of these three are connected to my hidden layer. Okay, this input layer, all the features in my input layer are connected to my hidden layer. Okay, I hope this much is clear. Now the hidden layer is going to perform two types of tasks. My hidden layer is going to perform two types of tasks. The first one is summation of xiwi plus b. So now what is summation of xiwi plus b? And the second task my hidden layer is going to perform is applying the activation function. Sir, what are these two tasks? Okay, so let's discuss these two tasks one by one. So tasks performed by hidden layer. The the very first task is summation of xiwi plus b. Sir, now what is this wi and what is this b? Sir, what is this w and what is this b? So w over here stands for weights. W over here stands for weights and B over here stands for bias. Sir, what are now weights and what are now bias? Sir, what are now weights and what are bias? Let's say I have these three columns, right? Study, sleep, and play. Am I right? Suppose now it is not necessary that the importance of all of these columns are equal, because as you can see over here, my sleep and my play in both of these two rows is common, right? The major factor that is causing the pass or fail in my data set is the study column. Am I right? The major column that is affecting whether the student is going to pass or fail is my study column. So can we say that the study column in my data set can we say that the study column in my data set is more important than these sleep and play columns? Can I say that the study column is more important in my data set than the sleep and play column? This means the weight for this particular study column will be greater than the weight for the sleep and weight for this play column. Weight is nothing but it denotes the importance of a particular column in my data set. Weight is nothing but it denotes weight is nothing but it denotes the importance of Importance of a particular column in my dataset. I hope this is clear now. I hope this is clear now. Okay, there's a question, sir. How can we say study column is important? I am in this data set. I am assuming my study column is important. Okay, because it is necessary that in some kind of data sets, some column will play a major role and some columns will play a minor role. So those columns that are playing a minor role will have a lesser weight value rather than those columns that are playing a major role. Okay, so I am assuming in this data set, study column is my major column. Okay, that is playing a major role whether the student is going to pass or fail. No, weights is not the study column. Weights is the importance of every column. Okay, I will have different weights. I will have different weights. Suppose x1 is my study, so I will have w1. Okay, if x1 is my study column, I will have weight 1 for this column. I will have weight 2 over here and weight 3 over here. Now, among all of these three weights, I will know the value, the importance of study is more. That means the weight 1 is going to be more, is greater. Similarly, sleep is like in between, so we will have weight 2 in between. I hope I am somewhat clear. Weight is nothing but the importance of each and every column. Now, sir, what is bias? Yes, weight is for individual column, not for only one column. Every column have their individual weights. Now, sir, what is bias? Have you ever heard of intercept? Have you ever heard of, like, this is a graph of mine? Have you ever heard of intercept? Like, if the line is passing through the origin, the intercept is 0. If the line is passing through, let's say this point is 2, then my intercept is 2. Have you heard of a single straight line equation that is y is equal to mx plus c? This c over here is nothing but the intercept. Am I right? So this intercept, this bias, we can call this bias very much similar to the intercept because this bias is used to provide flexibility to our model. Bias is used to provide flexibility to our model. I hope this is clear. I hope this much is clear. And this bias, one more thing to notice, this bias is common. Like, we have weights for each and every column, right? But we don't have bias for each and every column. Bias is constant. So the first task that we talked about is nothing but summation of xi wi plus b. That will give us x1 w1 plus x2 w2 plus x3 w3 plus b. I hope this is clear and I am going to denote it with y. Xi is nothing but the input. Over here, xi means nothing but the input. For first value, for first kind of value, the input is x1. For second, the input is x2. For third, the input is x3. So x1, xi denotes the input. I hope this much is clear. So the first task performed by my hidden layer is summation of xi wi plus bias. And this will be our output. Now the task 2. The task 2 is the application of activation function. Okay, task 2 performed by my hidden layer is the activation function. So now what is activation function? Sir, what is activation function now? In machine learning, we have heard about classification and regression, right? In classification, we get some kind of classes like male or female or true or false. And in regression, we get some kind of continuous value. Am I right? In classification, we get discrete value. And in regression, we get continuous value. Am I right? In machine learning, we have in machine learning under supervised learning, we have two categories. The first one is classification and the second one is regression. The classification means that we get some discrete value, and regression means that we get some continuous value. Similarly, in deep learning, we have activation functions. For examples, I will give you some types of activation functions, such as ReLU. Okay, so ReLU is an activation function, which the formula of ReLU is the formula is max of 0 comma y. Now, sir, what is this max of 0 comma y? Sir, what is this max of 0 comma y? Y is nothing. Y is nothing but the summation plus addition of bias part. That is x1 w1 plus x2 w2 plus x3 w3 plus b. Okay, so this is my bias. Oh, this is my y over here. So ReLU over here denotes ReLU over here denotes the regression. ReLU over here denotes the regression model, and the formula is max of 0 comma y. And if I will try to draw a graph over here for ReLU, if I will try to draw a graph for ReLU, I will get a graph like something like this. Okay, the value before, like when the value is positive, we will be getting the value of y, but before that, I am getting the value 0. ReLU will return me the maximum of 0 or y. Suppose the answer of this particular equation is 2. Okay, so I will get my point somewhat over here, that is 2. But suppose if the value of this equation is minus 3, so I will so maximum of 0 comma minus 3, I will be getting 0, which means I will be getting somewhat over here. I hope this is clear. So this is one type of activation function, that is ReLU. We have more than one activation functions. Suppose we want the classification problem. Okay, for classification we have sigmoid activation function. Okay, we have sigmoid activation function. Sigmoid is used for classification part. Sigmoid is used for classification part. Now if I will talk about sigmoid, the formula is 1 upon 1 plus e to the power minus y. Okay, this is the formula for sigmoid activation function. And over here, y is again nothing but equal to x summation of xi wi plus b. That is the same equation we are using over here, this whole equation. I hope this is clear now. Okay, now sir, if I will calculate this, if I will calculate this, I will always be getting my answer between 0 and 1. If I will calculate this, I will always be getting my answer between 0 and 1. So I will get a graph. I will get a graph somewhat like, I will get a graph somewhat like, I will get a graph somewhat like this. So I will always get a value between 0 to 1. Okay, I will always get a value between 0 to 1. Now what I am doing, I am taking that if my value is greater than 0.5, I am taking it as 1. And if my value is smaller than 0.5, smaller than and equal to, I am taking it as 0. So I will get a graph somewhat like this. Okay, which means that I am predicting between two categories, that is 0 or 1, which means sigmoid is used for classification part. I hope this much is clear. Is everything till now clear, guys? Is everything till now clear, guys? Great. There are like many activation functions, to be very honest. Like only ReLU have 3 to 4 types of activation function and many more. But I am just explaining you the important activation functions. Like we have understood the ReLU, we have understood the sigmoid activation function. These problems, yes, these problems and leaky ReLU are kind of part of ReLU. In leaky ReLU, we have a formula like 0.01x comma x and max. So all of these are like part of ReLUs and all. But right now, I'm not going to discuss all of these because we have a very limited time. So let's focus on forward. Okay, we have one more activation function. We have one more activation function, that is this softmax activation function. We have one more activation function, that is softmax activation function. Softmax activation function is used when we have to predict a multi-classification problem. Like we have deal with this iris CSV data, right? In which we have iris setosa, iris virginica, and iris versicolor. So in the case of that kind of data set, we have to predict between three categories. So there we use our softmax activation function. I hope this much is clear. So my hidden layer performs hidden layer and output layer, like in each and every layer, these two types of steps are performed. The first one is the summation of xiwi plus addition of bias, and the second one is the activation function. And after that, my output is given to the output layer and we get our final output. I hope this much is clear. I hope this much is clear, guys. So this flow is known as forward propagation. This flow is known as forward propagation. So what is forward propagation? Now what is forward propagation? In the forward propagation, the flow that we have studied right now, that first we take all the inputs, then these inputs are multiplied with the weights and the bias is added, then we apply the activation function and we get our final output. This flow is going in the forward direction, right? So that is why we call it forward propagation. Okay, if I talk about the steps, the first step is the multiplication of weights with inputs, that is summation of xiwi. Then the second step is addition of bias. The third step is getting the final output. Okay, we have done the summation of xiwi, then we have done the addition of bias, then the third step is activation function. Third step is activation function, and the fourth step is output, getting the final output. I hope this much is clear, guys. I hope this much is clear, guys. If everything till now is clear, write clear in the chat quickly. If everything till now is clear, write clear in the chat quickly, guys. Great, great, great. Amazing, guys. Okay, so moving forward. Let's suppose. I will just quickly, I'll just quickly copy this over here. Okay, not like this, but I want to copy this complete with my table over here. Just give me a second, okay? I will quickly copy this and I will quickly paste this over here. Oh, great. So moving forward. Now once again, suppose I have trained my model, okay? Suppose I have trained my model now. Now, let's say I just gave my model these examples, like the study is 2, sleep is 6, and play is 4. I must get the output 0. Okay, I must get the output 0. But let's say I am getting the output 1. Okay, I must get the output 0, but let's say I am getting the output 1. So can we say that my output is wrong? Can we say that my result is wrong over here? So yes, I am going to say that my result is wrong over here. So what I can do now? What I can do now to improve my model or to improve my result? First of all, I will calculate the loss now. Okay, I will calculate the loss. So I can see that the output I am getting is 1 and the output that must be there is 0. So can I say my loss is nothing but equal to 1? Can I say my loss is nothing but equal to 1? But my loss must be equal to 0 because the output must be equal to 0. So that is why I can say that I want my loss to be as close as possible to 0. I want my loss as close to 0 as possible. So actually this is not the formula for loss. Loss formula is like 1 by 2 and summation of all the values and all. But this is a very good technique to explain the things. Okay. So can I say that over here? Can I say that the output I am getting is 1, but the actual output must be 0? So can I say that my loss is 1 over here? Sir, this means we have to retrain our model. Sir, our model is that not that much good. Sir, we have to retrain our model. Sir, what can I do now? So what I will do, I this time I will move backward. This time I will move backward. I will first I will move backwards, and what will I do? I will update these weights of mine. I will update these weights of mine. I will move in the backward direction and I will update these weights of mine to train my model again. So how can we update our model? So while moving in the backward direction, the first weight we encounter, the first weight we encounter is our weight 4. Okay, so this is our weight 4. So the first weight that we encounter is our weight 4. So what I will do, I will change this weight 4 of mine. I will change this weight 4 of mine with the help of weight 4 new is equal to weight 4 old minus learning rate into partial derivative of loss with respect to partial derivative of weight 4 old. So this will be the formula for updating my weights. Okay, so this will be going to be my formula for updating my weights. I hope this is clear. I hope this is clear now. Now, sir, what is this formula? Can you explain me? Yes. So you guys must have heard about gradient descent, right? You guys must have heard about gradient descent, right? Have you guys heard about gradient descent? Guys, quickly tell me, have you guys heard about gradient descent? So, if you guys have not heard about gradient descent, just understand that gradient descent is kind of a, we can say, a curve in which we have some kind of points. Okay. So, my current weight is suppose this point. Suppose my current weight is this point. Okay. My current weight is denoting this W4 old. Okay. Suppose this is my W4 old. If you have not heard about gradient descent, leave it. Just remember that this is some kind of opposite bell shaped curve. Okay. And the point that I am marking is denoting my W4 old on the x axis. Okay. So let's say this is my W4 old. Okay, sir. Now the value, the value this DL by DW4 old is nothing but the slope. Okay. Is nothing but the slope of this point over here. This value is nothing but the slope of this point over here. Okay. If I try to find the slope of this point, if I try to find the slope of this point, I will get the slope as a positive value. Okay. I will get my slope as a positive value. So can I say that this value will be a positive value? So if my slope is positive, can I say that can I say that my learning rate is also some kind of value? I will explain it later on. Just understand this. Learning rate into my slope, that is a positive value. Will this all be also positive? Yes, sir, this will also be positive. So when I am subtracting W4 old minus some positive value, so I'm subtracting some kind of positive value. So can I say that my new value over here, my new value is smaller than my W4 old because I am subtracting some kind of positive value. So this means that I will move in the left direction. I will move in the left direction because my W4 new, my W4 new is some value lesser than the W4 old. Okay. Now my W4 new will be this new point. And if I will try to calculate the W4 new, W4 new, you can see my W4 new is now updated. Before moving backward, before moving backward, this was my W4 old. After moving backward, this is my new value. I hope this is clear. I hope this is clear. Is this clear, guys? Is this clear, guys? Yes. So as we move forward, if my point is lying on the right side of gradient descent, my weight is going to decrease. But sir, what if my point is in the left side? Sir, what if suppose my point is over here? This is my, let's say suppose this is my weight for old. Now sir, what will happen? So again we will calculate the slope. Again we will calculate the slope of this point. This time the slope will become a negative value. This time the slope will become a negative value. Sir, this means this whole will be a negative value. Yes. Sir, which means my learning rate will also be multiplied with a negative value, which means this complete will be a negative value now. Yes, sir. Sir, which means if I now try to calculate my W4 old, now if I try to calculate my W4 new, it will be W4 new is equal to W4 old minus some kind of negative value. Okay, sir. This means we are going to add something to my W4 old. This means because negative negative leads to positive, right? So this means we are going to add some positive value to my W4 old, which means I am going to move in the right direction, and this will be my new W4 new. This will be my W4 new. So if my point is on the left side, if my point is on the left side, I will move in the right direction. If my point will be on the right side, I will move in the left direction. I hope this much is clear. And if this is not clear, so you have to see the mathematical reasoning, mathematical intuition behind logistic regression or linear regression, not logistic, linear regression. Then it will be more clear to you guys. I hope this is clear, guys. Great. So this is how one by one we will be changing or updating our weights. Okay, this is how one by one we will be updating our weights, and these weights are updated with the help of optimizers. We have different optimizers, and these weights are updated with the help of optimizers, and this whole process is known as backward propagation. So now what is backward propagation? In backward propagation, the first step is we calculate the loss. The first step is we calculate the loss. In the second step, we find in the second step we move in the backward direction and we update the weights. Updation of weights. And in the third step we again move forward. This means that just give me a second. Yes, this means that first of all what we are doing, first of all we are multiplying our input with our weights, then we are then we are adding the bias, and we are applying the activation function, we are getting the output, then we are calculating the loss function, then we are updating all of the weights. After updating all of the weights, we are again we are again multiplying the input with the weights, again applying the activation function, again getting the output, again we are going to calculate the loss function. If the loss is again high, then we will again be updating our weights, and this whole cycle keeps going on until and unless we get our model a good model. I hope this is clear, guys. Now till now we have talked about single layered neural network. Okay, it is not like we only can have only one hidden neuron and all, but we can have multiple hidden layers as well, with multiple neural networks, with multiple neurons. Suppose this is how. Yes, so this is also one of the model. Let's say in this we have two hidden layers, one output layer and one input layer. Okay, in this model these two are my hidden layers. This is my output layer, and this is my input layer. So this is a multi-layered neural network. This is a multi-layered neural network. Okay. Now at what point we will know our model is good to go? A great question. So there are number of epochs that we set. Epochs is nothing but the number of cycles we want to get our model. Okay. So sometimes we take 50 epochs, sometimes we take 100 epochs. So we can take as many epochs as we want. We can say our model is good to go when the weights and when we can say we get our global minima, when we get the points as much close to global minima as we can. Okay. So this is the whole theory behind neural network. Okay, this is the base theory behind neural networks, because deep learning is a very vast field. Deep learning is a very vast field, and there are many topics to discover more, but this is the base for each and every topic. This forward propagation, backward propagation, neural networks, this is the base for each and every topic. So this must be very much clear. Now let's move on to the coding part. So I will quickly go to Collab. And yes, So the very first thing, we are going to import the libraries. The one thing I told you guys, in machine learning we are going to use the sklearn library, but in deep learning we are going to use the TensorFlow library. Okay, so the very first thing we have imported is NumPy. Okay, import NumPy as NP. The second thing we imported is TensorFlow as TF. Okay, the second thing we used is TensorFlow as TF. Then we have written from TensorFlow dot keras dot models import sequential model. Okay, so everything that we are going to apply, like our layers, our neurons and all, we are going to apply under a sequential model. Okay, like all the things that we are going to apply, such as our layers, number of hidden layers, number of neurons in each layer, everything will be applied under sequential model. Then sir, what is this dense? From the import itself you can say dense is a layer. Okay, dense is a technique through which we can apply our hidden layer and output layer and input layer. Okay, dense is a technique through which we can apply our input layers, hidden layers and output layers. Then the next thing is again, we have used the load iris dataset. We have used the train test split to split our training data and testing, split in training data and testing data. And we have used standard scaler and label binarizer. Now the next thing is, yes, I will quickly run this cell. The next thing is we have loaded our data set over here and we have performed standard scaler over here. So this label binarizer is nothing but it also just, we can say, um converts our values like iris setosa into 0, iris virginica into 1 and all and all. It is similar as label encoder. Okay. Then we have splitted our dataset into training part and testing part. I have already explained what is this test size and what is this random state and all. Okay. Now coming to the deep learning part over here. So sequential is my model. Okay. So I've called it model is equal to sequential. Then to add my layers, to add my layer, I have written dense over here and 10. Sir, what is 10 now? 10 is the number of neurons in my hidden layer 1. 10 is the number of neurons in my hidden layer 1. Then my second parameter is input shape. Sir, sir, according to this data set, if I will just enter, just give me a second, okay? I will enter X. Sir, this is my data set, okay? Okay, just give me a second. Yes. Sir, this is my data set. Sir, we can clearly see that this is only our input values, okay? Sir, we can clearly see that we have 4 input variables over here. We have 4 input variables over here. Sir, this means we have 4 neurons in our input layer. Okay. Sir, we have 4 neurons in our input layer. Okay, sir. Okay, sir, we totally understood. We have 4 inputs in our input layer, 4 neurons in our input layer. Then we have applied a dense layer, which also we call our hidden layer, with 10. Sir, what is this 10? 10 is the number of hidden neurons. 10 is the number of hidden neurons, which means I have 10 neurons, 1, 2, 3, 4 and all and all and all. I have 10 neurons in my hidden layer. Okay, this is my hidden layer 1 and I have 10 neurons in my hidden layer 1. Then we have our second hidden layer because we have applied dense for the second time. We have written 8 over here. So what is this 8 means? This 8 means we have 8 neurons in our hidden layer 2. This means we have 8 neurons 1, 2, 3, 4, and on and all. We have hidden layer 2, and in hidden layer 2 we have 8 neurons. Sorry, in hidden layer 2 we have 8 neurons. I hope this much is clear. Okay, sir. So let's again go to the hidden layer 1. Sir, it denotes that this is dense, denotes that this is a hidden layer. Okay, sir. 10 denotes that we have 10 neurons. Okay, sir. Sir, input shape is equal to 4 comma space. Sir, what is this input shape now? Input shape is nothing but the number of neurons in our input layer. Okay. So as you can see, we have 4 neurons in our input layer. So that is why we have written input shape is equal to 4. Now, sir, what is this activation is equal to ReLU? Sir, ReLU you told us is used for regression. Sir, you told us ReLU is used for regression or when we want multiple outcomes, right? So, sir, why are we using ReLU? We are using ReLU because we know that each and every neuron is connected to more than one neuron. Okay, each and every neuron is connected to more than one neuron. So that is why we are using ReLU to get multiple outcomes, because we can get any continuous value, right? Xiwi can be any value, right? It is not like Xiwi will be only a single value, let's say 0 or 1 or 2 or 3. Not only these four values. It can be any value. Xiwi can be any value. So that is why we are using ReLU over here. Again, sir, in the second dense layer, we have 8 neurons and we have activation equal to ReLU. So this means each and every neuron of this hidden layer as well is connected to the hidden layer 2, and again it is ReLU, which means because weight and xi can be any value. Okay, sir. Then in the third layer we have dense 3 and activation equal to softmax. This means we have 3 neurons. This is my output layer now. This is my output layer now, which means I have 3 neurons in my output layer. And sir, why are we using softmax? Sir, we have used ReLU in the above two. Then why are we using softmax? Softmax is used when we have a multi-classification problem. When we have a multi-classification problem, we use softmax. Okay, sir. So I will quickly run this cell. Then we have to, after defining our model, we have to compile our model. Sir, how can I compile? There are some parameters that we have to write. The first one is optimizer. Sir, what is optimizer? I have already told you optimizer is used to update the weights in my model. Okay, optimizer is used to update the weights in my model. And if you guys want, you can just go to Google optimizers in deep learning and you can find out different types of optimizers in deep learning. Okay, like there is static gradient descent. Oh, this is the type of gradient descent, sorry. Let me just go to optimizers in deep learning. Yes, here you can see different activation functions. These are the optimizers. So there are many types of optimizers as well. Okay, so you can just simply go to Google and read about the optimizers and all. But optimizers are generally used for a better weight addition, we can say. Okay, then we have loss. So what is loss? Loss is nothing but we calculate it to update our weights, okay, or to check how much good our model is. Okay, so we have used categorical cross entropy. So there are many other types of losses as well. So again, you can just go to Google and check out for different types of losses. Types of losses in deep learning. So you can see these are all the types of losses in deep learning. Okay. And the third thing is metrics. We have taken accuracy as our metric. We have used accuracy in yesterday's lecture as well. So you guys must know. We can give any number of neurons. Okay, it is not like we can give only 20 neurons or 30 neurons. We can give any number of neurons, but taking excessive neurons may lead to sometimes a bad model as well. Okay, taking excessive neurons or excessive hidden layers may lead to a bad model as well sometimes. Then I have simply done model.fit. Okay, I have fitted my model using model.fit. I have given the parameters xtrain, ytrain. This is nothing but my training data. Now I have given epochs. Sir, what is this epochs? Epochs means I have written epochs is equal to 50, which means I want 50 cycles. One cycle consists of the forward propagation, then backward propagation, right? I want 50 cycles like this, consisting of forward propagation, backward, forward, backward, forward, backward. Like this, I want 50 cycles. That is why I have written epochs is equal to 50. Batch size is equal to 8, which means my model is going to train in 8 batches. And verbose is equal to 1. I have also explained this verbose concept in the previous lecture. Verbose means nothing but how much information I want to see on my model. So as you can see, my epochs are quickly training. As complex model you are going to take, the epochs will take more and more time. Okay, but this model is a very basic model. That is why I am getting a like the epochs are trained very quickly. And at the end, you can see the model over here gave the accuracy 100%. But we can clearly say that this is a case of what we call um, this is a case of overfitting. So I am just going to train my model again. Let's hope we get a better accuracy this time. If I just run the model, okay, it's giving 100%. So what I can do to get a better model, I can increase the number of neurons as well. Okay, let's take 18 neurons in the first layer, then 10 neurons in the second layer. Okay, now I will again train my model. Now if I will just check the accuracy, okay, it's again giving 10. So what you can do, you can take different neurons. If you want, you can either add one more layer as well to check on change your accuracy. I hope how to train these models is now clear to you guys. Okay, what if I do? I will just remove one of the layer and I will take 10 over here. Let's try this as well. Modeled, okay, sorry. Let's try one more time. Okay, so this time we are getting an accuracy of 96.67%. So I hope this is clear now. I hope everything is clear now, guys. Now I will just give me a second, okay? I will quickly give you the link for attendance so that you can also fill out the attendance form. Okay. Yes. The attendance link is there in the chat, guys. So please quickly fill out the attendance form And if you guys have any kind of doubt, you can ask. If you guys have any kind of doubt, you guys can ask. Else, please quickly fill out the attendance form. The link is there in the chat. What is the best model according for training and testing? So it is not like a single model can perform good in each type of data. So the best model depends on the data you are using or the quality of your data, type of your data. So on the basis of that, you take different and different models. Okay, it is not like one model can perform well on each and every type of data. Anything else, guys? The accuracy is like, if you get an accuracy between 90 to 95%, it is great. Why do we use neural networks? So because like in machine learning, we use pre-trained models, right? We use linear regression, logistic regression, and all. These are all pre-trained models. So we use neural networks to like create our own models. Okay, with the help of neural networks, we can create our own models. Notes are, I have provided the notes from my side, and maybe the notes are also uploaded. But if not, then please wait. I hope the notes will be uploaded soon. If the notes are not provided, please wait till today or tomorrow. I hope the notes will be provided soon. Sequential is the model we are using in which we are applying the all the hidden layers and everything. So we, you can say sequential is the container in which we are adding everything. Yes, yes, good question. So there are many techniques. One of the techniques is early stopping as well. So these techniques are used when, like, before completing all the epochs, you reach your best accuracy or something, right? So this early stopping helps you to break the code in between and give you the best outcome, so that no further epochs are trained on. So there are many techniques you can learn about. So, to learn machine learning and deep learning, there are many courses available on YouTube as well, or you can externally join different classes or batches as well. But there are many resources on YouTube as well that are freely available. So you can go and just watch those resources as well. The project is like nothing but actually we have understood like how can we train our models through machine learning and deep learning, right? So the project must most probably will be like you have to train your own model on any of the data set, either it's classification and or regression, and you have to achieve the best accuracy possible, and then you have to submit it. The WhatsApp community link will be, is there, I think so, is there in the community chat description, this YouTube video description. So you can just go through that. I have provided the collab notebooks from my side. I hope those will be uploaded or updated soon enough. Yes, it's a very good thing if you do the projects by yourself from this bootcamp, because it will be a very good practice for you guys as well. Yes, yes, you can also do what we have done in the class for the project as well, nothing else. So, okay, how can we train the model using images? So, actually, if I will tell you, we have learned deep learning, right? In deep learning, we have three categories. The first one is ANN, that is artificial neural network. The second one is CNN, that is convolution neural networks. And the third one is RNN, that is recurrent neural networks. So the thing that we have studied till now, that is forward propagation, backward, optimizers, losses, and all of this comes under the ANN part, that is artificial neural networks. So we train or we deal with images, videos, sound waves in CNN part. That is a little advanced, we can say. Okay. So we learn about the how to train images and all in CNN. That is convolution neural networks. Guys, the attendance form is there in the chat, so please quickly fill out the attendance form. The meet will be, I will over the meet in 2 to 3 minutes. So please quickly fill out the attendance form first. All the information, all the guidelines related to the project will be given to you guys in the community only. In in ANN, we make our own classification or regression model. Like I have shown you, right? We have made a classification model. So this is the similar way in ANN. We make our own classification or regression models. The project submission deadline, all the information regarding the project and everything will be shared to you guys through the community only. RNN is used for when we have to deal with languages or text or everything. Okay. I hope everything is clear now. And please quickly fill out the attendance form. The link to the WhatsApp community is there in the in description. So please, I hope it is in the YouTube video description. So you can access the WhatsApp community from there. Thanks a lot for joining today, guys. Let's meet tomorrow for the final day of this amazing bootcamp. Everything regarding the project will be told to you guys in the next lecture, so don't worry. Yes, if you guys have filled out the attendance, you guys can leave. Else, please quickly fill out the attendance form that is there in the chat. Thanks a lot for joining today, guys. Let's meet tomorrow at the same time, that is 7 o'clock. And if you guys have not filled out the attendance form, then please fill it quickly. Thanks a lot for joining, guys. This is it for today. Thank you. Let's meet tomorrow on the same time, that is 7 o'clock.